Yeah, very
Good morning, Vietnam. Very professional. All right. Oh, it's back on the two screens. It's weird. All right. So today we're just going to finish off a little bit of the lecture on correlations, and then after that, I just want to hear a little bit about the journals, the art studies that you guys critiqued, because I'm gonna try to bring some of that into the class today, and we'll talk about internal validity. I wanted to record this especially because the lecture on external or internal validity is the basis of the rest of the class for methodology. Every journal article critique will be on today's lecture. Your methodology critique is based on the threats to internal validity. So this is a really important one. So I just want to make sure I recorded it for people. So we ended, well, last thing I showed you was how you could do a scatter plot of two groups. But there's two types of correlations. So we have bivariate, which is what you're doing for your assignment. So that's a correlation between two variables. And we also have partial correlations. So that is controlling for one variable. I'll show a diagram. So let's say we have our x and y variables dependent. And obviously a bivariate correlation is looking at the variance that is shared between two variables, like a Venn diagram. A partial correlation adds a third variable. For example, so let's say age. And so what it does is it takes out the variability that age, or whatever your third variable is, that is shared between your x and your y. So we're removing this and just looking at the variability between two variables without the variability that is shared by a third. So for example, you might have heard some people will say that they, like in an experiment, in a statistical analysis, they'll say they controlled for age. Have you ever heard that? This was controlled for age. You always hear that. That means that they didn't do it at the experimental level, okay? Obviously, if you controlled for age in an experiment, how you collected people, that would be better. Let's say having all 18-year-olds or all 19-year-olds or something. But often you can't do that. So what you do is before you start your data analysis, you do a partial correlation, you remove the variance that age is shared, and you save your variables as a new one. And it then is taking out or removing the variability. And that's what a partial one is. And you could do it with more even. You could keep going on and on. There are basically several types of correlations. So the main one that you're probably familiar with is the Pearson correlation. It is looked at as a little r, not a big R. Big R we'll talk about later. That's about shared variance overall, r squared. The data has to be at the interval or ratio, so that means a continuous variable or a scale, and it has to be normally distributed. So when you do a Pearson, when you do a correlation, you have to look at the variability, or sorry, at the normality of the data with the KS test. And you can see, you guys have seen this before, but I just say, you have to say a bivariate correlation, that you did. It's always important to actually say which kind you did. You'll see a lot of people don't say that. They'll just say, we did a correlation. Well, that's nice. Tell me which one. There's tens and tens of different kinds of correlations. So you have to tell the reader which type. And we then want to say, when we're reporting it, we want to tell the reader if it's significant, statistically significant or not. Obviously, you would look at the p-value. We want to tell the reader if it's positive or negative. So in this case, we have 0.25, so that means there's a positive relationship. You want to also think about this that makes sense. Like in this case, I forget what we're doing. Restriction in an activity and depression. So that makes sense. The more restricted the person was in their sports, the more depressed they were. So that makes sense. But as an example, my student Kenny, we were just running a whole bunch of correlations on Monday, and he had some weird ones. Like some of them, actually, we found the greater physical activity, the greater the depression. Okay? Now, it wasn't statistically significant, but it was. So that made us like, oh, something's weird. Like, you wouldn't expect that. So we went into the data. Actually ended up, there was, it worked better if we were looking at people in different groups. I won't go into all that, but there was it helped us to think about how to do something else. And you want to also then say if the strength of the correlation. So I've told you a rule of thumb is Cohen. If it's 0.1, to 0.2, that's viewed as a small. 0.34 is moderate. 0.5 higher is large. So, and I said this was moderate. In my world, it's moderate. I mentioned to you though, if you wrote in a paper to Dave Bain that a 0.25 was a moderate correlation, he would laugh at you, because in physiology, that's very small, okay? So you'll see that in like all the statistical literature is giving you the rules that I'm giving, but then there's like a specific view in each field of what a strong correlation is, okay? And so I'm also then explaining to the reader. I'm not just saying it's significant and it was positive. I'm telling the reader what that means. It means greater restriction, greater depression. So when I grade the assignment, I have like a rubric that I look for all this stuff. So for example, in your assignment, I'm going to look. Did you state what type of correlation you did? Did you provide a rationale? Did you cite it? Just use the textbook. Okay. Did you, for style, I'm going to look that you've got a little r, and that's italicized and all that. Did you report the exact p-value, and did you interpret it correctly? Did you say if it was significant, the direction of it, and the strength of it, and then did you explain that to the reader? And I basically go checky, check, check. Okay, that's how it works. Now, an R squared is simply a measure of the amount of variability in one variable that is explained by the other. It's just another expression of Pearson. And it's simply, you square the R. So for example, in this case, we've got a 0.25. So R squared is 0.25 times 0.25 equals 0.0625. That is a percentage. So that now means that 6.3% of the variance in depression is explained by restriction in sports and recreation. Now, do you think that's a high relationship? Strong? Explaining 6.3% of something? Yeah, no, it's bad, okay? So in a study, you ideally want to be explaining a lot of variance. So the conclusion in this study would be, well, there must be a lot more variables that are important to explaining depression. And so you want to do further analysis to find, it's just not a good association. So usually, I had R squareds of, 0.8. So that's like 80% of the variance explained. That's a good one. So when you're R squared, your R squared is useful for a couple things. One, it allows you to compare statistical models. We're not going to get into all that right now. And it's a standardized way of comparing, different types of studies. It's a type of effect size in a way. And also it's really useful to see if you need to do other studies, or maybe this means I should have been including more variables in the model, or etc. So you usually want to report R squared as well. Then we have spearmint. And in SPSS, the options under correlations are Spearman, or Pearson, Spearmint, and Kendall's tau. I think those are the only three buttons that you can check. Actually, I'll just show you that quickly. So this by the way, here's the partial correlation. So if I want to do a partial correlation, I could put two variables in here. Oh, you can't see anything. What's going on? I don't know what's happening. Okay, just a second. Why would that matter? Okay, let me just a second. Brief technical difficulties. What the bejeebies? Okay, and I'm gonna have to, can I pause it? Okay. Sorry guys, I don't know what is going on. It is showing this. Okay. You guys can talk and stuff. It's too creepy. All right, just a second. I'm stopping this. Am I stop? Did I stop it?